Good afternoon. So let's start our workshop today. We'll talk about Tanzu for Kubernetes operators. Let me get the clicker here. There we go. So this is what we're going to go over today. Introduce myself and Michael. We'll introduce ourselves. We'll talk a little about how we constructed this lab and how we did this in hands-on labs and how everything works. Talk a little bit about what is TKO, and then we will start our lab. We have selected a few of the modules so we can go over with you guys, and please stick until the end. We will have at the end of our session some people from the Tanzu team, marketing team. We'll have some swag to deliver for you guys, so hang on to the end, and we have nice swag for everyone. So my name is Mauricio. I'm Senior Manager for the Multi-Cloud Management Solutions Architecture. I live in Brazil, and I'm responsible for this team in Latin America. I've been in VMware almost for 5 years. I started here as an NSX engineer, transitioned to this multi-cloud management role, and I've been in the IT industry almost for 20 years. Worked for Cisco. I have a big background in networking. In hands-on labs, I've been here this is my 3rd year as a captain. And Michael?
Hey everybody, my name is Michael Fleischer. I am a Senior Staff Solution Architect with VMware. My journey has gone from customer, so as VMware customer, I was a global VMware architect, storage architect, Linux architect, a whole bunch of good stuff on the customer side. Then I worked for a partner for a year, and now I've been with VMware, there it is, about 5 years. So in 5 days, it'll be my 5-year anniversary. I'm a Tanzu Kubernetes subject matter expert, much like Mauricio here. I'm an Office of the CTO Ambassador at VMware. VMware Code Coach, alumni VMUG leader. I led the VMUG in Philly for 5 years prior to joining VMware, and I'm a 8-year vExpert. So this is my 4th year as a hands-on lab captain. All have been supporting the Tanzu labs. First 2 years were remote, as we all know. VMworld 2020 and 2021 were remote, so now it's been 2 years on site. That is my lovely family on the right side. So that is my wife and I in Napa, California, 2 months ago now on our 10-year anniversary, and it was amazing. That is our brand new puppy on the right that we got about a month ago now, and he's amazing. And those are my 3 amazing children that are 7, 5, and 3, and always crazy, but great.
Thank you. So, this lab, all our VMware hands-on labs, they use what we call a vPod. A vPod is basically a collection of virtual machines, and we use a nested environment, and each lab is based on a specific vPod that has a certain number of VMs, ESXi hosts, and other VMs that help make up the lab. That's what we call a vPod. So, we have this vPod where we use vSphere with Tanzu. It's based on vSphere 8 Update 1, so we have all the newest versions in this lab. It is totally integrated with NSX Advanced Load Balancer. So all we do here for service type load balancer or Ingress, it is integrated with NSX. And the whole solution is based on Tanzu on vSphere. Just so you get an idea of how big this vPod is, we have 1.4 terabytes of storage, 380 gig of RAM, over 120 vCPUs. So it's quite a big infrastructure to create these vPods, and each one of you, when you log in, you are logging into one of these vPods, so just multiply how many people we have here. You can see the size of the infrastructure we have. I like a lot the big screen on the entrance of HOL because it gives a dimension of how big this is, and however many people we have using labs, we have one of these vPods dedicated to you. And this is just how it works. It's a nested environment. We have the different VMs. So we have a vCenter, a main console, which is the Linux console that we use to access our environment. We have 4 ESXi hosts, a FreeNAS, the Alvi controller. There's a vPod router that connects all the different subnets that we have, and we can have Through that, we have external access. For example, TMC is a SaaS offering, and we use that vPod router to connect to it, and we have a couple of different networks. What else? This is, all we do here is, this lab is totally based on Kubernetes Grid service. So it's not that standalone. We did have an older version of this lab that was based on TKG standalone, and now we're doing this in the Tanzu Kubernetes Grid service. So what is TKO? This is a specific lab for TKO. We have Containers 101 lab, we have the vSphere, with Tanzu lab also. We have other labs. At the end, we will show you a list of other labs that you can learn a little bit more about. But basically, what VMware has done is created an offering that is aimed at the people who create and maintain the platform that is used for our developers. And this is, I think all of you know, developers, they want to have a Kubernetes offering. The apps and based on containers, they are vital to their businesses. And it is difficult to track when you have an offering and you have to offer these platforms for your developers. It's hard to have security policies that are consistent across different clouds and different types of offerings. And that's where TKO comes in, because the reality we see in many customers is that these Kubernetes clusters, they are spread around. So they might be in a public cloud like EKS or AKS clusters. We might have them in our private clouds. There are different flavors of these. And although for our developers this is great because they can deploy their applications wherever they want, it is hard for the person, for you guys needing to manage this. It's hard because they're different. It's very hard to have consistent management of such different Kubernetes offering. So what TKO creates, I'll go over what are the different functions and products that are part of TKO, but basically we have a global control plane where we connect all these clusters to a global control plane, and this enables us to have a service mesh with different types of Kubernetes clusters, so you can have one microservice in one Kubernetes cluster, other microservice in another cluster, and they will connect securely with each other through MTLS tunnels. And this is part of, so the service mesh is the first thing that comprises TKO. We have the Kubernetes cluster, the Kubernetes service, Tanzu service inside of vSphere. We have the service mesh, which creates a global control plane. We have also the part of observability. So how can we measure our applications? How is our user experiencing and accessing our applications? This is offered by, this comes in from area operations for applications. So it's bundled into the TKO offering as well. And at the end, we have, in the management layer, we have Tanzu Mission Control. So Tanzu Mission Control is the Kubernetes fleet management service, that it is a SaaS-based service. We have an option to install it as a standalone. This is something new. So it's basically how do we manage multiple clusters, lifecycle manage our clusters. So there are two ways to use TMC. We can either attach current clusters that we already have. For example, EKS, AKS, you can get a cluster. We'll show this in the lab. We have an EKS cluster. You can attach it, or you can have TMC directly create your clusters. So in vSphere 8, when we have the Tanzu service enabled, we create what we call a supervisor cluster. TMC connects to the supervisor clusters and does all the lifecycle management, can create policy, and we'll go over some part of that in our lab. So depending on the type of cluster, and if Tanzu Mission Control was the one who created the cluster, it will also be able to lifecycle manage. If we just attach the clusters, the lifecycle management has to be done outside of TMC. And The service mesh is spread across all these containers, all these different clusters. And we have the RA operations for apps. This is just building on upon the last slide. This is the last slide we have, so we can just start diving into our lab. This is just the overarching benefits that you get with TKO. And we can have VMware services for Tanzu Labs, where we can have our experts help you out in building a Kubernetes environment for delivering your applications. So enough of this, let's start going into the lab. We have picked these 3 modules. So we have an introduction. I talked a little bit about what TKO is. We'll start in module 2. How do we build a secure Kubernetes stack? So how is the vSphere service enabled on our vCenter, VMware environment? And then we'll go to TMC and a little bit about backup and restore. So I'll go over now module 2, and then I'll pass it on to Michael in a while so he can take you through modules 2 and 3. Let me shift here. I'm going to open up the browser. I think you should all be already connected. If you're not, our lab number is 24, this is the old lab, 2433-02, VMware Tanzu for Kubernetes Operations. Start this lab. And this is quite quick. Does anybody have a problem accessing this lab? Please raise your hand. We can help you. If you have any problems accessing something, Michael can help out, and then we'll switch roles here. He'll do the other modules, and I'll be able to help out. But you should all be getting ready in your lab. And we are going to start in module 2. So if you click here in the table of contents, go here to module 2. So there's the first part of this lab is telling you what is a Kubernetes, Kubernetes service over vSphere, what are the different versions we have. I'm going to skip, and we are actually going to start on, page number 29. So page number 29, we're going to open our Firefox browser and see what we have set up. So we have running here in a vCenter. So vCenter should open up. The username and password is saved for your use. And if we take a look at region 01A, this is where we have our different vSphere clusters. Moving on, page 31, let's take a look of our workload management. So this is where we enabled. So we have pre-enabled this service, done this installation, so it's all ready for you. And here in the workload management, we can see that we have what we call the supervisor cluster. The supervisor cluster is a cluster that is created on top of vSphere. So you can use what we call the cluster API. So cluster API is a Kubernetes API that is used for lifecycle management, creating clusters. And whenever we're going to log into this and show some operations that we can do with Kubernetes clusters, but we log into this, and this gives you the ability to use cluster APIs for lifecycle management, gives also the ability to create policies, user policy. So we'll go here, I'll show you the namespaces, which is where you create your offerings, and where you can have, for example, a namespace for your developers, or maybe a namespace for your certain application, and you can have different permissions for your users. So once we're in here, we can see that the cluster is running. This is important. It should be all in running state. We have 3 hosts. And we have this concept of a vSphere namespace. So if we come back here in our inventory, you will notice in each of these clusters, doesn't matter if it's number 1, 2, or 3, you will see we have something called a vSphere namespace. So everything that we create on vSphere with Tanzu, we separate, we use these namespaces to organize, and the supervisor cluster, it's outside of the namespace because it is the one that we use to create new clusters. But if you open the ecom01 stage, you will see that we already have pre-created a TKG cluster 01 for you, where we have a couple of nodes, and it's spread out in these 3 different clusters, so we can have high availability. We use something that's new in vSphere 8 called vSphere zones, where each of these clusters, we put it's the objective of this is to have the concept of failure domains. So each cluster is a failure domain, and when we create this cluster using the cluster API, the Tanzu CLI, we'll get into that, and our cluster manifest says that we want to have our nodes spread out across these different failure domains. It will spread them out, so if we lose a cluster, it will not impact our Kubernetes cluster. So if we lose a vSphere cluster, it will not impact our Kubernetes cluster. And that's down there I talk about a little bit about vSphere zones, but that's what I just explained for you. Another thing we have is we can configure. We have specific configurations for our namespace. So if we click on the namespace, there's this option to manage namespace. So there's lots of different information that we have here. For example, I talked about permissions. So it's integrated with vSphere SSO, and you can give users different permissions in different namespaces. One of the things also that is interesting here is we can see our different compute resources, which are our Kubernetes clusters. So you can see here we have TKG cluster 01. It should be with 3 worker counts. We have the Kubernetes version. What is the control plane VIP address, so we can use the Kubernetes API. So this is all pre-configured for you, so we can start using the Kubernetes cluster. We'll deploy a few applications later on. So let's go now to number 38. I went all over this, right? So we already saw that our cluster is working. I'm going to skip a few steps here, just so we can actually start using this TKG cluster. First thing we're going to do, let's access PuTTY. We have this Linux 01 box where we have installed Kubernetes CLI, the kubectl. We have the Tanzu CLI that we use to manage our clusters. And it should auto log in for all of you. I'm going to zoom in a little bit, see if it helps. Doesn't help, right? So once you log in, what we're going to do, so remember I showed you in the namespaces we have permissions. So in order to have access to the Kubernetes API, we need to first log in. So we have this special command where we do the login to the vSphere, to the supervisor cluster, where we have the IP address of the supervisor cluster, the username, so we're logging in here with the vCenter administrator password, username. It's not going to ask you for a password because we have already saved that as an environment variable in this Linux 01 box. But once you do that, you should be logged in. And if you do either a kubectl command, or for example, if I wanted, since this is a supervisor cluster, I can do a Tanzu cluster list, and I can see that, in fact, my TKG cluster 01 is running. It's in the ecom01 stage. namespace, 3 control plane, 3 worker nodes, and that's my Kubernetes version. So the same thing, same view we showed here in the vCenter, we can get the same view with the Kubernetes, with the kubectl Tanzu command, sorry. So we have some things that we can do inside inside the namespace. For example, we can create a new cluster. We can work scaling this cluster. So the next steps here in our lab manual are for lifecycle managing this cluster that we already have, or either creating a new one. So one thing that's important is that since we have multiple clusters, we have the supervisor cluster, and we have the namespaces, you will see with the command kubectx, where we can switch contexts and see which context we are currently in. So if we want to switch contexts, all you have to do is kubectx, and let's go to the ecom 01 stage. Context. If I do just the kubectx, you can see we're currently at the namespace level. One of the things we can do is take a look at our cluster. So this cluster was already pre-created, and if we proceed a little bit in the lab, we have in page, let me see which page it is. This is on page 46. It's optional. You can do it if you want. I'm not going to do it here because it takes a while, but feel free. The environment was built to do this. What we can do here in page number 46, we have created, so if you go into the labs folder, we have a labs folder, and if you take a look here, we have a folder called Tanzu cluster. This Tanzu cluster, we have some YAML files that define, they're the manifest for how we want to create the clusters in our environment. There's the TKG cluster class AZ availability zone that we use to create this first cluster. And we have a TKG cluster 02 YAML file that if we apply this YAML file, it will go consume the cluster API and create a new cluster called TKG cluster 02. Let me just show this file to you and go and examine it so you can get an idea of how we can create these manifests and create a new Kubernetes cluster. So basically we have to say what's the name of my cluster, in which namespace it's going in, the different CIDR blocks. And this is interesting because in the topology, we have what's our version of Kubernetes we're going to use, how many control plane nodes, how many worker nodes. We have in the environment some VM classes that we have to create, so the different sizes of these machines that we're going to use, which storage, so we have a storage class, we have a storage policy that we have created. So this tells the cluster API how it should go into creating this, what image it will use, what storage these VMs will be in, and if you want to try it out in your lab, the command to use is Tanzu cluster create -f, the name of your YAML file. I'm not going to run it here, but feel free if you want to run it. That's not a problem. It will just take some time to create this cluster. In 10, 15 minutes, it will have created 6 new VMs, and your Kubernetes cluster will come up. But feel free, so in page 46, all you have to do is copy and paste this command, and it will create your new cluster. And if you use the Tanzu cluster list, you will see that we will have a new cluster being created, and we have all those screenshots here. The operation I do want to do today in this lab, just for sake of time, is a cluster scale up. So we might find ourselves in a situation where we need new members for new worker nodes, and one thing that we can do is scale our cluster. So if we copy and paste this command, Tanzu cluster, scale, the name of the cluster, there's a typo. I gotta fix this one because there's a typo. We need a space after the cluster name, and it's in namespace ecom01. So if you run this, it will tell you cluster is being scaled. And if we do Tanzu cluster list, where is it? There it is. We can see now that in the worker node count, instead of 3 out of 3, we have 3 out of 4. When we do that, what's going on in the background is in vSphere, if you take a look at your tasks, you'll see it's deploying a new OVF template, and it's creating a new VM, and it will join this new VM to our Kubernetes cluster, and in a few minutes we'll have 4 running worker nodes. We can go back here and take a look in a few minutes how this went, but let's proceed here, and if you want to scale down, just run the command with the -W3, that also works. And let's now start using and consuming, deploying an application in our environment. Let me just take a look at time so I can, okay, very good. Let's start, to deploy applications in our cluster, remember we logged into our supervisor cluster. We are already logged in. But if you want, you can log into a specific Kubernetes cluster. So this command, I'm going to execute it. What it does, it's a little different than the command that we logged into the supervisor cluster, because now we are logging in to the specific cluster that we created, that we pre-created in the ecom01 stage namespace. So the basic difference from this command and the other one that we give, we specify with the option Tanzu Kubernetes cluster name, the cluster name, and the namespace it is in. So when I do enter here, it will simply log into that cluster. Remember, we have to give permissions to our SSO users, and these permissions can be to the namespaces, and a user might have permission in one namespace and might not have in another. But since we're using the vSphere administrator password, we have full access to all of them. And if you do a kubectx, you'll see that after this command, it already changes the context to the TKG cluster 01. So any kubectl commands we run now, they will be run, they will go to the TKG 01 cluster Kubernetes API server. Let's skip 51 because this is already done. And we have some applications that we've deployed here. I'm going to, since there are a couple of applications, we have one application that we worked with Harbor. I'm also going to skip this one, but Harbor, these labs will all be available. They are already available in the self-paced lab. So for the sake of time, we have to and not go over the full modules because there's lots of things to go over. But one of the things that this is available so you can test it out on your own, and in about a couple of weeks, these labs will also be released publicly, and you can have access to them and take it when you're back home with more time. But one of the things this lab has is the container registry called Harbor, where we can push images, and there's a few steps here where we do that. We create a new image based on an Nginx image. We manipulate the index.html file. I won't cover that right now. And the image that we are going to deploy, the application that we are going to deploy today, is the microservices application, which is the Spring Pet Clinic. So if we go to page 68, we have a microservice Nginx. That Nginx exercise is basically an exercise to see how you consume these images in the Docker in our registry, the Harbor registry, and since it's just a web server, we have an application that is based on microservices, which is the Spec Clinic application, where we have a database, we have an application service, and this is what we're going to deploy just to see if our cluster is working right, we can access our application, and give the benefit of having Kubernetes clusters to our developers. So if we go to the labs folder, we have a folder inside that called Pet Clinic. So I'm in my home folder, labs, Pet Clinic. I have a few files here, a few folders in which I have some YAML files. And what we have, first thing we'll do is apply and create a MySQL service. Something that's interesting, that we have something that's called a VM service. We can use, what this does is, we can use the Kubernetes API to create virtual machines. So when we run vSphere with Tanzu, we are not only able to create lifecycle, the clusters themselves and have container-based applications, we can use and we can give our developers access to creating virtual machines using the Kubernetes API. Since the MySQL service for our application is not based on a container, it's a VM, we need to switch to the ecom01 namespace, because that's where we'll create our virtual machine. Let me switch to the kubectx namespace. Let's take a look, just so you see the difference between these different YAML files. There's a MySQL, and inside there, VM service, VDS, is it this? VM service, VM, VDS YAML file. So this is a YAML file that has the configuration of the MySQL service. We have ports that it will be listening on. So 3306, it's MySQL. We have, it will be in the ecom01 stage. So this is basically the configuration of the VM that we want to create using the VM service. So let's apply this YAML file. So once we do that, you'll see that it created a virtual machine. So there's the virtual machine operator, and if we go to our Firefox, open up the recent tasks, we will see that it just started creating a new VM called MySQL CentOS. So we have this image in our already in a content catalog, and it will deploy this. It's based on CentOS. And what's nice is we are able to deliver, and not only for creating VMs, we can use the kubectl, the Kubernetes API, we can also see these VMs. The same way that we can use kubectl get pods to see the pods that are running in Kubernetes, we can use kubectl get VMs. It's the equivalent of the Kubernetes get pod. And we can see here what VMs are running. And we have the MySQL VM, so that's running. Remember, we are in the context ecom01 stage. So what this will do is show you all VMs that were created. We have 7 VMs that were created, which are our Kubernetes nodes. We have 3 master, and now we have 4 worker nodes. Remember, we did a scale up to have 4. That's why we have 4 machines here. This one you can see 8 minutes ago. That was the last one that we scaled our cluster, and we have the MySQL over here. So this is something nice. And we can see, for example, the status of this VM, if it's This is just another command to see if it's running or not. It's not ready yet. It doesn't have an IP address assigned yet, but it should power up and everything should work in a few minutes. We can get service, so the same as we do with pods. There's the load balancer. We have an external IP. It has a cluster IP because it's service type load balancer. If we go to our AVI, the NSX Advanced Load Balancer, we will see that it also created a VIP, and that's how this machine can be accessed using that external IP. So if we just wait and give it some time, this machine will come up, the VM will come up, and while we do that, let's do two things. I'm just going to do that Tanzu cluster list just to make sure that my VM, the scale up, worked. Here it is. So we have now remember we had 3 out of 4 workers, now we have 4 out of 4. Everything's working fine, now our scale up worked. So let's go back to the Spec Clinic app. So now we are going to do, so we deployed a VM using the VM service in the ecom01 stage. Now we are going to the TKG cluster so we can deploy the rest of the other components of our Pet Clinic app that are based on containers. So let's kubectx TKG cluster 01. In this Pet Clinic folder, we have a folder inside it, a Pet Clinic Kubernetes. Let's go into that one. Let me just do an ls. Pet Clinic Kubernetes. So we have a namespace, we have some deployments and some services inside here. So let's start creating our application. First thing we'll do is, this is just simply creating a namespace. We apply that, so we now have Pet Clinic namespace. If I do a kubectl get namespace, I can see the Spring Pet Clinic. It's there. So let's proceed and create the rest of the services that we have and the YAML files that we have. There's an option we can use. We have this services folder where we have multiple YAML files, so we can let me see here, services, CD, Pet Clinic, Kubernetes. We have the services, and we have a bunch of YAML files here, right? Let me just go, we have to go out of this folder. Pet Clinic, here it is. So once you are in the labs Pet Clinic folder, when we apply, we didn't specify any YAML file, it simply applies all the YAML files that were inside here. So if you see what I listed before, there's a secret, there's a config map, a role, there's lots of things, and you can see this is exactly what we've been creating. It simply applied all those YAML files. And if we look at the service, it should have created a service. And we have an external IP, which is our API gateway, so we can access this application. Before it works, we just need to, this is just to get the endpoints. Let me do that, just so I can tell you what we have. So we have the different components, the different microservices that compose our application, and now we can apply in the deployments. We'll actually deploy the different deployments that make up our application.
It's not the current folder.
Yeah.
You're saying current folder, and then Pet Clinic is trying to go down an extra level.
So No, there's a typo here. This is Kubernetes. There we go. Sorry about that typo. So all the deployments are now created. And we should have a bunch of pods for this pet clinic. So we're gonna, the -W option is to watch, and we can see here if the container creating once it is running. So it's coming up, these new services, they're coming up, the visit service came up, and when we have all 1 out of 1, means all these different pods were created, they're running, and we can actually test our application. Give it a while. While it does that, let me just get the service again, the Spring Pet Clinic service. So I know which IP I have to access. So this is the external IP for the application. Let me save that. Seems I have everything ready. Control-C gets out of here. So I'll go back to the Firefox browser, try to access it. Here's my application. So basically, this is what I wanted to show you in this module. And it's what we showed here is the Tanzu service inside of vSphere, where we create clusters, we can scale clusters, we can do lifecycle management, and this enables us to create complex types of applications that can be made up of different VMs, that can be made up of containers. That's why I like to show this Pet Clinic app, because it shows the benefit of having the Kubernetes API, not only to create containers, but also to create virtual machines. I'm going to pass it on to Michael now. He will take you on through using TMC, managing this cluster, and then a backup and restore. Go ahead.
All right. Can everybody hear me? We're good? Awesome. All right, like Mauricio said, we're going to go through, first of all, Tanzu Mission Control, which again is Kubernetes fleet management. So let's say we have a whole bunch of Kubernetes clusters, we want to manage them in one spot through a SaaS service. That is what we're going to go through first. And then, like he said, backup and restore. We'll deploy a new application, we'll back it up, we'll act like a really bad admin and we'll blow it away, and then we're going to recover it as it was in about 2.5 seconds. It's really great. All right, so to start here, we're going to hop into, whoops, not that one. We're going to hop into module, where am I here? Module 3, so it's marked as 4 in the manual, but it's module 3. All right, so we went over what Tanzu Mission Control is, so I'm going to fast forward through this and get to the login screen here, the login walkthrough. Almost there, I promise. There we go, okay. So what we need to do here is, so there's all these cool scripts behind the scenes that do a student check-in. So each of you has a login to TMC that gets created. It's actually really cool. We were just working on looking at the scripts earlier. It's really cool how it all works. So the first thing we're going to do now that Firefox is already open is we're going to click student check-in. And then you will have to enter your email address that you use to log into the labs here. So, well, it's actually Christian Lamson. So I'm going to have to be Christian Lamson for the moment, which is not my name. He's an awesome person that works over there. But I'm going to be C. Lamson, I believe it is, at VMware.com. I know, good, it worked. Okay, cool. So we're going to, as I said, enter your email address that you logged in with, and then we're going to click Platform Admin Login. Okay, and so when that loads, you will see it created you a separate account that has the Cloud Services Cloud Services Portal. There it is, CSP login to TMC. So then we'll click Next. It will prompt for password, and it is the most famous password in history, which is capital V, capital M, where, lowercase, one bang. One exclamation point, I should say. And again, I'm just kind of doing this by memory, so I'll skip through here on the slides. But again, so like I said, that the password is right here, if you need that. And then the next thing we're going to do here is we're going to actually hop right into the Tanzu Mission Control Lab, or service. So once you get logged in here, scroll down a little bit, you'll see My Services, which is what your account has access to in CSP. We're going to click Launch Service under Mission Control. And this takes just a few seconds here. Okay, so mine is now logged in here. I'll give everybody else a second or two for it to come up. But what we're going to do here first, again, there's lots of functionality in here, lots of features. Not going to go over them all today, clearly, but what we're going to do is the Tanzu Kubernetes cluster that you were working with Mauricio a little bit ago, we're going to attach that here into Tanzu Mission Control, so you can see it from the GUI up here in this SaaS service, and we can check on its health, right? All the services within it, they'll all be populated in there. You'll be able to see what's going on. So some of this does take a couple of minutes once we click a button, so you'll see me tap dance here for a little bit, but we're going to get through this together. So the first thing we're going to do here is, so the good news is some of the stuff we can skip because we're already logged in where we need to be over here. So the first thing we'll do, let's check to see which context we're in on the Kubernetes cluster. And the good news is we're already on where we have to go, so we don't have to do anything else there. As long as you're all following along, that is where we should be. So if you were doing something else in the lab, what you want to do is do a kubectx space TKG cluster 01. So I'll just do it here just so it's clear and on the screen. Whoops. There we go. Okay, so I am, again, now in that context. So what we're going to want to do here is, so we did all this login stuff. Sorry, let me just get to myself to the right spot here. There we go. So we're first going to want to click on cluster groups here, which is on the top left of the left-hand bar in Tanzu Mission Control. And if you scroll down a little bit, you will see that a cluster group has been created for you. This is all part of that scripting I was talking about on the back end, just so you were all ready with the right controls and access to get you to be able to attach a cluster. So what we're going to do is click on that. And then we are going to click Add Cluster. And we want the bottom choice, which is Attach Cluster. So when that pops up here, let's give this a unique name. So this would be, again, a human readable name that you can understand, hey, this cluster is this and this is why. So I'm going to name this one as it says in the manual here. I'm going to name it TKG Cluster 01 - my username, which I'm going to actually use my username this time, not Mr. Lampson's, even though he's a fantastic person. And we're going to choose the cluster group that was auto-created, not HOL demo. That is for something else we're going to be looking at here in a second, and that is read-only. We're going to choose the one that says my VMware, insert 3 numbers here, dash VMware-HOL.com, or -com. And once that's populated, we're going to click next, because all the other stuff is optional and we're not going to worry about it here. Same with the next step, you'll see 2 no's, perfect. So when you click next, you will see a nice, lovely command pop up. And what this is a manifest that was created by Tanzu Mission Control that says, hey, these are the packages we need to install in this Kubernetes cluster to get it managed by TMC. So what we're going to do here is, if you see there is a little blue button that's kind of hidden sometimes, I'm going to click that because you'll see copy to keyboard pop up, or copy to clipboard, I'm sorry. So I click that, get the nice little green check mark. That means I have that kubectl create from a file command copied. I'm going to hop back into PuTTY here, and I'm going to paste this right here. So just note the paste is not right click like it normally is in PuTTY. It's so click the mouse wheel, the scroll wheel, click that, and it'll paste for you without a problem. So I click the middle mouse button, I'm going to hit enter. And oh look, it's creating stuff, so that's super cool. So right now, that script, it went out, it pulled down the script, the YAML file that it needs to deploy the necessary resources to attach this cluster to TMC. And what we're going to do now is actually watch it happen on the fly. So as that's running, if you skip to page 104 of the manual, there is this command here. It says watch N1, so every second we're going to sit here and watch this update. So again, this is where the tap dancing starts, so I'm sorry, so I'm going to have to, we'll watch the paint dry here together. But what you'll see is new containers start to get pulled down from the service. They start to run in the namespace VMware-system-TMC. And as more and more of these pop up, I believe there's one called TMC Observer, here it is. So once we see TMC Observer popped up, that means we are good to go. This usually takes between 30 seconds and a minute to 2 minutes. So again, let's just, let's stand here and watch this together. Oh, I see TMC Observer and it's almost ready. 1 of 1. Boom, that was, oh wait. Pinniped, oh never mind. Might need to change the manual, Mauricio. There's more things, but let's give this another couple seconds here. All right, I see one that still says 0 of 1. 1 of 1, all right. So that looks right to me. So that is everything that it needed to pull down, and that is all of them being ready, because you see 1 of 1 or 2 of 2. So now that that is complete, let's hop back over to Tanzu Mission Control. And you're going to want to scroll down to the bottom here and click the Verify Connection button. And if all goes well, you will see success. So again, that was as easy as it is to take one of your local clusters, attach it to TMC, so that you can now visualize it in our SaaS service. So if I go ahead and click View My Cluster, this does take a couple minutes here. But as I refresh, eventually this will come up and say healthy. And you'll see a whole bunch of the service. All right, there we go. See, we already got some of the services talking back, so that's cool. So we've got that going. Oh, worker nodes are healthy. Okay, we're almost there. Just because I'm a completionist, I am going to wait for this to say healthy before we move on. I promise it'll happen quickly. There we go. Okay, so now our cluster that we are working with on our in our vPod within our data center is now connected to this SaaS service, and this is all live. We are actually using the real Tanzu Mission Control service that we have available. Okay, so the other thing I want to show you here is we have an EKS cluster running in AWS, so it's their managed service for Kubernetes. We have a cluster running, and we have it attached to Tanzu Mission Control here for you already. So to take a look at that, if we go back to cluster groups here on the top left, and you click the HOL demo one that I told you not to choose earlier, you will see, if you scroll down, that there is an EKS cluster here. So again, this was provisioned by, actually probably was provisioned by us using TMC, but this is an EKS cluster that is sitting out in Amazon. And as you see, just as you saw the other cluster that we attached here, same sort of stats. And we've got all the components, we've got the agents, we've got the health of each, and we have that all visible here. So again, doesn't matter where the Kubernetes cluster is, it can be monitored and managed here by Tanzu Mission Control. So that is what I want to show for that piece today. Now we're going to jump into the fun stuff, which is the backup and restore. This won't take long in a good way. It's amazing how fast it is. So let me hop into the manual in the correct spot here so you can follow along. And this is module 6. So the first couple of pages here talk about Valero and Restic, which are the two products that we use to back up our clusters. So what we're going to be doing today is, I think I mentioned this earlier, but we're going to be deploying an Nginx service or pod. We'll log into that. It's just It's just an Nginx server that's sitting there running a little website that says, hey, welcome to Nginx. Hop into that, see it working, then we're going to back it up, and then we're going to do, again, what the bad admin does, and whoops, I clicked the wrong button, or I entered the wrong command, and I deleted the whole thing. We'll recover it, and we'll see it come back up. So the first thing I want to do here is actually hop into Firefox, open a new browser window, and we're going to browse to, you'll see why in a second here, 192.168.110.100, and you can always drag and drop that from the manual here, :9000. So what this is MinIO, which is an S3 compliant object store. So Valero uses S3 buckets to back up our data to and recover from. So this is running local to the lab here. I stood this up when we were building this lab. Super easy to get going, right? If you want to just test, if you want to test our functionality very quickly, or you can use an S3 bucket, or you could make this highly scalable and make it a true production environment. Multiple ways to do it, but what we're doing here today is using MinIO. So the way to log in, as it says in the manual there, is MinIO admin. And so I have already created a bucket for you here, and Valero is configured to use this bucket as the backup target. But I hopped in here just to, after we do the backup, we'll hop back in here to see that the object number is not 0, to show that it was backed up properly. So let's leave that open for now. And the next thing we're going to do is, well, thankfully we already have this done, log into the Tanzu Kubernetes cluster. So if you hop back into PuTTY, so the watch command is still running if you were following along, so I'm going to Control-C and kill that. But we are in the correct spot here, which is on the Linux 01A VM, and we're already authenticated to the TKC cluster, so we don't have to do any of this, which is great. And just for completion's sake, let's make sure we're in the right context, which I know we are because we were, yep. So we can skip that page too because we're good to go. All right, so now let's deploy, like I said, the quick Nginx application so we can see that that we have something to back up and that we can verify. So if you copy and paste these commands over, first thing we're going to do is create a small namespace called Nginx. So now we're going to deploy the Nginx application into that namespace. And this is all very specific for a reason, you'll see why in a second. We're going to browse to a folder, so it's home folder labs Nginx. That's where the YAML file is housed. So once we're in there, we're going to run the kubectl apply command, -f, which means file, nginx.yaml, and the -n nginx means put it in that Nginx namespace we just created, please. So if I run that, this should happen very quickly. It did. Okay, so that is now created. Let's run this command here to make sure that all is well and make sure it's all ready to be verified. So from my end, I have 3 Nginx pods running, which is great, and they're all in the all in the running in the 1.1 state. Last thing we'll do here is let's find out which IP was given to this application so we can actually access it, because that would be helpful, right? So if I happen to mine, you may get a different IP, obviously, because it's all dynamic. Mine is 192.168.130.16. So let's hop back over to Firefox and just verify that this whole thing is running. 192.168.130. I already forget, that's how, and I didn't copy it. 130.16. Okay, boom. Quickly deployed a new application. So that is now running. I just browsed to it. So let's take a nice backup of this because this is now our production application and we don't want it to go away. So hopping back to the Linux box here, we are going to tell Valero, hey Valero, create a new backup called Nginx backup, and please include the entire namespace Nginx. So that will include the namespace itself, as well as the pods below it, and anything else that's dedicated to that namespace. So if I run this command, boop, so that was sent. So now let's take a look and see if it completed. So if I run this command here, which basically says, hey Valero, can you describe that backup to me? We called it Nginx backup, let's see what happened. So if it's a long return, right? But Of note, there is something here that says completed and it's green, which says to me, we're good to go. So that is all it takes to back up something using Velero. Again, to set this up does not take long either, so if you really want to get something going so you can back up the applications, it's pretty darn cool, I got to say that. So now, it's backed up. We know it, we verified it, quote unquote. Obviously anybody can back up, not everybody can restore. I've said that a million times in my life as an admin. But it says completed and it's green, which means clearly it's good, right? So, let's do a recovery. So we can skip through this part. This is just logging back into MinIO. But if we hop over to it, let's check and make sure we have object in here, like I said before. So if I'm in here, I refresh, and oh look, 9, that's bigger than 0. So that means we did something. Hopefully the right something, but we did something. So now, again, let's be super bad admins and run a command without verifying anything. So let's just go ahead and delete the deployment of Nginx. Running this command, if I can get it to copy, there we go. So I'm going to go ahead and say, hey, that deployment that's in the Nginx namespace, get rid of it, please. Boop, gone. So if I run this command to check, just to make sure it actually did delete. Uh-oh. And then the last thing, that namespace, we don't need that either, do we? Because clearly that was not production. So if I run that command here, kubectl delete namespace Nginx, it does. It takes a second or two to come back, but it's deleted. So now, while that finishes running, there we go, that is complete now. If I hop back over here, it might be cached, but I'm going to hit refresh and see if it says nope. Oh good, okay, so the application is gone. It's spinning, saying, there's nothing on that IP address, what are you talking about? Just at that moment, my phone rang, and my developers were like, what the heck did you do? Production's down. So what do we do at that point? Well, we did take that backup. So let's take a look at recovering from that backup. So if I hop back into the Linux box and run this delightful little command, Velero restore create from backup, what we named it, Nginx backup. All right, something happened. It says submitted successfully. Let's take a look and see if it actually did do anything. Bam, it says completed. So now if I scroll back up a couple commands here, and I say get that deployment, well, that looks pretty good. Let's take a look at the services as well. Yep, something's back up, and it's on the same IP. Let's hop back over to Firefox and make sure that that I can calm people down. Oh, look, it's back. So again, super quick and easy to back things up in Kubernetes. And beyond all this, so this is just me backing up a namespace and the pods within it, and the application and the service and all that good stuff. You can back up an entire cluster and say, I want everything in this cluster and everything that I've described this cluster as to be backed up. Velero will do that as well. This is a stateless app, so again, it's super quick and easy to back up, but Velero plus Restic, which is installed here as well, will do a full stateful app as well. Yes? Yeah.
How do we know what's the IP again? Let's say if I forgot what the IP was.
The IP, sorry, the question is, how do I know which IP it was for the Nginx application here? Yeah. Absolutely, so if I hop back into the Linux box here, this command, this kubectl get service -n Nginx. So I'm saying, hey, anything in the Nginx namespace, can I have the services there? So if I run that, that's where it comes back and says, my external IP is this. So that's what's exposed from Kubernetes. Awesome. But yeah, like I said, stateful, stateless, full clusters, easy to back up and restore using Velero and Restic. Good to go? All right.
I think so. If anybody has a question, we have some extra minutes here. There's one thing that I'd like to show that's part of this lab. It's not on the manual, but one of the things we have here is the NSX Advanced Load Balancer. So what's nice here is all these different applications we created, we have access that we have to expose these containers, because these containers, they all, remember when we created the cluster, we have those different CIDRs. So we have containers in private IP addresses that are not exposed, they're not externally accessible. And we expose these services through two types, typically two types of Kubernetes service. First one that we're using here is a service called service type load balancer. That is a layer 4 load balancing, and you can use whatever type of ports you need to do, your application is running on. But basically when we do that, you will see here, if you go to virtual services, so let me just go, I might have gone a little fast. All you have to do is open up a new tab, go to region A, NSX ALB. Sometimes we call this AVI, because that's where the old name of this product. And you will see here in virtual services, application virtual services, you will see a bunch of different applications. Let me see if I do zoom out here, if I can get more things. What's interesting here is each time we apply a YAML file that has either a service type load balancer or a service type ingress, the difference between one and the other is the load balancer is a layer 4 VIP, ingress is layer 7. Ingress, we can have, for example, install our secrets here and all the the certificates that we need to access our application securely. AVI will take care of all that. For example, the Nginx one that Michael, this application that Michael created, the Nginx 13016, it's one of the VIPs that we have here, so it's my second one. If I click that name, it will bring you nice information regarding, so we have to give it a while, so it builds up this, the analytics part. But one thing that I really like about the integrated experience that NSX Advanced Load Balancer creates is, from the moment you deploy an application, it will create, so there's a specific pod that is running inside a Kubernetes cluster. I can even show you that. If you do a kubectl get namespace, you will see that there is a namespace. Where is it? It's supposed to be here. But we do have a pod here that's running that listens to the Kubernetes API and translates those to the commands that the AVI, in fact, we do have that, but I think it's on the supervisor cluster, that's why I didn't show it there. But let's go back to Firefox. What I want to show you and give the message to you, and it's as easy as deploying an application. The VIP will be created. We started getting some action there, so just appeared a new configuration here. These are events that they show, and it'll start building up lots of different important information regarding the analytics to your application. So we have a few metrics here. For example, we have a nice metric, which is the application, the latency, your application latency. So it will start building this analytics, and to do that, you don't have to do anything. So from the moment this application starts and your users start consuming, we will start seeing a bunch of different metrics for analytics. We will see logs. If we have any errors in our application, it will show here. You'll see the logs, reclassify them as non-significant or significant logs, any 500 errors, whatever is going on in our application. Each time we renew, we refresh our browser and access the application again, it'll start showing these logs. So there's lots of things we can do. If we have security needs, you can apply a WAF policy, so you can have web application file. There are lots of things that we can explore from here. I'd like to show this. And so we can get closer to our end, then do a wrap up. First of all, I hope you liked our lab. Unfortunately, we don't have enough time to go over every single thing that we put up in our lab, but this is just a single lab. We have other labs, other self-paced labs, as I said before. These will all be available to you in about a couple weeks. We will publish this catalog in the HOL, and lots and lots. We have, I think, more than 50 new labs that we are showcasing today and during VMware Explore. So we have other labs related to Kubernetes and Tanzu content. We do have an NSX Advanced Load Balancer. If you are a little bit curious about what I said, we have those other labs also. We have other ELWs, so we have both the self-paced labs, and some of those labs, we also have other expert-led workshops going on tomorrow and Thursday. So if you want to take other ELWs, come over by. If you're not registered, we should have enough capacity because you'll just arrive 15 minutes before. We should be able to accommodate everyone. And we also have some sessions, breakout sessions that I like to invite you to be part of. We have our VMware booth where we have the Tanzu specialists. Michael and myself will be here. As soon as we end this, we'll be happy to talk to you. And we have lots of other people on VMware in our booth that can talk about the Tanzu product portfolio. Please take the survey once you end this lab. So it's important that you end this lab, go to finish lab, and it will pop up a survey. That is important to you, for us to see. Tell us what you thought about this workshop, our content. So anything that you have to say, please say it in the survey. We also have lots of resources for learning. We have Cube Academy, we have Pathfinder, we have a developer center, lots and lots of different and interesting things. So let me just fix this typo. There we go. Lots of interesting material. I leave that for you to later dive deeper in. And I think that's what I have. Thank you again for your time. Thank you, Michael. It was a pleasure showing this lab to you. And we'll stick around. We still have 10, 15 minutes where we'll be happy to chat with you. Thank you.